Okay. I wanted to get a stream in to work on the virtual memory visualizer. So let's get started on that. And I did some work on this last week off stream. Just to, I think I fixed like some stuff with the makefile. Yeah, I cleaned up the makefile. I did some basic culling, which actually worked out pretty well. But I guess I gotta make clean. Yeah. But it's still like this. Just a big, huge array of bytes. But it's performant because it's doing the culling now. So you can zoom in. It's actually quite nice. So I guess the thing I want to work on today is, so there's like a hierarchy of memory, not the traditional memory hierarchy, but there's a hierarchy in which memory is organized, virtual memory. So you have the maps, which are like the big blocks of memory that are mapped into your process address space. And then inside those maps, these are all page aligned blocks of memory. You'll have pages. And then inside those pages, you'll then have the individual cache lines and bytes inside those cache lines. So it's kind of like the hierarchy I want to work with in my program. And I also want to visually display that hierarchy as well. Because currently I'm just showing a huge array of bytes. So let's go ahead and go to, I guess I can start in main here. So I have this fake map thing. It has a start, a length, a remote adder. Oh yeah, that's the struct for like where it's located remotely. So that has to be 64 byte aligned. So we'll just do like 128 there. And then next would be the next map. Yeah, but I'm not specifying that field. I don't think I should. Yeah, just leave that blank, hopefully. So let's do two maps. So the first one is there. This is going to be rather large. It's 1 to the power 20. So that's 1 meg. And I guess we can do another one here. So you say, hey, register a map. The start is going to be... Why did I call this one page? This is not one page. This is, we'll just say first. Sorry. Let's do code rename. Just call this first page, or first map. I'll just call it first. And then we'll do the same thing for second here. And we'll keep it the same size, different data. So we're gonna say, hey, register the map first. This will be, start is gonna be second buff. We'll call it buff. First buff. That's going to, of course, need to be updated here. Okay, second buff. Okay, size of first buff, 128, first buff. So this remote adder is going to actually be some amount off of 1 meg. So I'm going to say you're going to be actually at, so one page would be 64 bytes. No, sorry, 64 bytes of one cache line. So this need to be 4K to be at one page boundary. 4096 here. And then the remote adder here would be 1 to the power of 21 should be sufficient. Oops. I did my bit shifting in the wrong direction. There we go. Okay, so that should be the second buff. I should actually say the size. They're the same size, but I can fix that. Okay, so we say register map. The start is the second buff. The length is the length of the second buff, and then the remote adder is going to be that. And I think that's all that's in the map T except for the next field, which is of course populated by the registering. So if I go to, it's called map.h, map.c. So the register map it should update the next fields, right? So the first register map comes in here. It looks at the register start, which is going to be empty. Zero value is going to be null. So you say, hey, get a pointer to that thing, and then also get the thing that the value of the pointer. A pointer to the pointer and a value of the pointer. And while the value of the pointer is not equal to null, we're going to dereference it, grab its next value. Until we find something as null, and then we're going to say, okay, your next value, or potentially the start, we're going to assign into that map, which will be the pointer to the map T. Okay, so that works. All right. Just wanted to review that real quick. And then if we go under draw, so we're going to go into this draw loop. That's the main thing. Of course, that's a header file. So if we go under here, oops, draw.c, we'll have draw maps. There's a draw loop. Draw loop. So goes in its loop. Write visibility state. What does this thing do again? Okay. That just writes the screen width and height as a vector. So I don't really like that it's called bottom right, because I guess technically it is bottom right, but it's, yeah, okay, that's fine. Alright, let's go back up here. What is it? Draw loop. Alright, then we go into our draw maps. We give it a registry. We say, hey, start at the start and just draw every map that you see. The problem here is that draw map, I'm actually going to comment out everything in here, because this is more like the drawing the cells of the map, or really the cells of the page. So this is more like a draw page. The draw map, so this will be start cursor is equal to 0, and we could call this a an auto UL. Okay, I really don't like it when it does that. So you have our cursor, and then we say, oh, but draw map. We need to store the cursor outside of this. Start is going to be a unsigned long. Then down here, we need to maintain the cursor. Auto, let's do it like that. Cursor, draw map, cursor. So draw map's going to need to return that, the updated cursor value. So this will need to be a unsigned long. So here, map dot, arrow, length, and we're gonna need to mod that by 4096, just size of a page, just find out how many pages. Auto. Is the lens size T? Yeah. Okay. So we have our pages. How many pages are we gonna need? How many pages do we want to draw? Pages divided by pages per row. And we'll just do a static const. I think you just say const. I don't think I have to say static const. Pages per row is equal to what, like 32 maybe? And then in here, pages divided by pages per row. This will give us rows. And then now we know how many rows we're going to need. These are page rows. Not including the remainder though. That truncates downwards. Here we can say if page rows, oops, plus plus, if we have pages modded but pages per row is not equal to 0, then we have to give it an extra row. Okay. So here now we need to do our drawing. I'm gonna do black for this. Just I'll fix it in a bit. It doesn't have to be black forever. But draw a rectangle, black. Oops. Black. And then our rectangle we need to construct here. So the X position will be we'll leave it like that. We'll say grab these guys. Why is it size in 2 dimensions? That seems like a weird name. Okay, it's width and height. So we got X, Y, width and height. Width. Oops. And height. Okay. And then X position is basically going to be, let's delete all this. It's going to be a start. That's our Y position. Our X position is going to be 0. Y position is going to be start. Width is going to be, we'll just make it like page width. And height will be page rows times page row height. And then we'll just have to compute these. Auto page row width and height. So the height will be, we'll just make these static for now and then I'll come back and fix them. Page row width is going to be size of a page width times pages per row. And this would be page row height would be just page height. And then auto page width and page height. We'll just make these, so these are going to be dependent on the size of the individual byte cells. So we'll just compute it now here. Let's see here. Here we go. Size 50 UL. So we'll say 50. We'll pull this out as a constant. Static constant auto is equal to 50 UL. And we'll give it a name of bytes. We'll call it cell size. And then here, it's 50 UL here. We'll call that cell size. Okay. Then up here, the page width. So the actual page width is going to be 64 times cell size plus margin 15 UL. Cell margin. And then down here, we just call that cell margin. Okay, it's approximately equal to the cell margin. I mean, it's not going to be exact, but. And then the page height, so that's the width, is 64 cells. It's pretty much going to be the same size as the page width for now. And that might change in the future, but that is what it is for now. Okay, let's go ahead and make that. Okay, we got some issues here because of the next field. And then this thing does not return. That would be a good idea to return, or else none of this is going to work. So draw a map here. We need to return here, which is going to be return start plus the height. So we got that missing next field. Do I need to do that if I give it the actual field names? Oops. If I say dot start dot dot len and dot remote adder. Yeah, that fixes it. So let's go do that. Dot start. It's always better to give the field names when you're doing the, I forget the name of this. It's complex. What is it called? Oh, I forget the name of this. But when you're doing the struct initialization, where you give it the value, the field values as positional arguments to the initialization, that's more brittle than if you give it named values. So my inlay hints here are giving me the name values, but I want to actually explicitly give it to them like that. And it shouldn't be a negative one, it should just be a regular one. Alright. That gets rid of all the warnings. And the idea being there is that, well, first of all, I got rid of the warning, which is good because, actually, let me get my chat going on here. Do I have, yeah, let me do that. Can I pop out the chat here? Yep. Bam. All right, back to what I was saying. The struct initialization, if you provide positional arguments to struct initialization, it's brittle in that it's reliant on the ordering of the structs in the fields in the struct. So if you go through and reorder fields, you can get a compiler error, or worse, not get a compiler error and get a implicit failure, like a runtime failure. Whereas when you explicitly name the fields, unless you do something where you rename the fields, the compiler's gonna catch it for you. So it guards against that, which is nice. It also guards against like situations where if you add a field in the future, you don't get these compiler warnings. So yeah, it's generally a good idea to do it that way. All right, let's run it. It's probably looks like it's working. Oh, no. Well, maybe. It drew that there. I'm wondering if I zoom out a lot, if I can see like another pixel show up down here. Basically the height didn't get set, so something got messed up there. All right, let's go back to our definition of our rectangle. Y position. Y position is the start, and then width and height. Let's go ahead and just print out the state of this rectangle before we draw it. So print f out x position. Actually, I like to start running my debugger on this. In Vim, or say nvim, on a C file, how do you easily set a break point so that when you compile and run the program with GDB, You don't have to tell it where to set the breakpoint. It's like a static breakpoint. Built-in trap. Okay. Let's go ahead and do that. Built-in trap. Call it like that. Can I just say trap? Yeah. So I can just say trap. No, it doesn't give it to me. So let's say under built-in trap function. Okay. And then if I do make here and then run gdb on build. Oops. Nope. Okay. So we hit our why am I didn't draw maps? Maybe because it got optimized away. Show was this layout TUI layout code help TUI layout sorry TUI layout source. That's what I want. So we set our breakpoint inside the draw maps and it's not showing us. Let's just do like a continue maybe. Illegal instruction. Okay, that's great. Restart. Okay, so now it's going into draw loop. Built-in debug trap. Okay. Yeah, I was gonna say I don't want to get a sig ill. I want a built-in debug trap. Okay, let's kill that. Yeah, quit. Foreground. Built-in debug trap. Make. There we go. So now I can say restart. Yes. There we go. Draw map. It'd be weird because up here, yeah, I guess I was in the same location. Okay, good. Let's print out our X pose. Print out our Y pose. And then print out our width. Print out our height. Height was optimized out. Something's wrong with this height. What if I say next? Rect. Can't do next. Step. Help. That was next. Yeah. Next. Okay, so now we gotta print out our rect height. Okay. Print rect. Okay. So that's our problem right there. We got a 4160 on our height. Well, that's wrong. And if we continue the next one and go next, next, and restart, yes. Okay, L. That's what I want. Alright, so it's saying that I'm on 121. So if I print out like rec, it's gonna be, I don't know what that is. So I'm gonna hit next. Does that go to draw rect? Now it's saying I'm in draw maps. So that's the thing I don't understand. It's like how I got down there. So I went from draw map into draw maps by going next. Okay. Let's do, we'll say step. Step. Okay, now we're at the draw rec. Now we can say print rec. That's our bad rec. So now we're going to continue. Step, step. And then we're going to print our rect out. Same width and height. So it drew itself twice in the same position. So two bugs here. The height calculation is wrong. And the width calculation likely is wrong. Maybe it isn't, but suffice to say, it should be different between these two. So let's go back into here. Look at how our width is not computing right here. So width is equal to page per row. How did I do that? Page row width. Yeah, that should be correct. So the height was wrong. That's what it was. Page rows plus page row height. That should be a times, first of all. Amount of page rows times the height per row. And then you also have to add on the offset of our start. Otherwise, we're not using start correctly. No, start is there. Okay. Okay, that should be good. All right, let's go ahead and we'll take back our breakpoint here. Oops, did I close that? Didn't mean to do that. Draw. Trip. All right. Make. And we'll just go ahead and run it directly. Okay, so now we're getting like nothing drawn to the screen. So that's wrong, obviously. Instead of doing this debug, I'm just going to print out, since we only have two maps, print rect. Is there like already like a function for that? I wonder. Print? No. Let's look for rectangle. So we have the struct itself. It's embedded in some other things. Draw rectangle. Collision stuff. Image stuff. Textures. More fonts. Okay. Just be nice if we had like a. Is there a debugging tool in C that can print out a structure of arbitrary type without having to specify all of the fields? The fields, something similar to spew and go. GDB has it, obviously. Generate printers with macros. Okay. Just says use a debugger. I don't want to do that, so let's go ahead and say edit under source debug.c, and then in here we're going to say print. We'll do a macro thing. So here we have pound define person fields, name, age, doing this X thing, person dump, define X, field format, printf field format, and then p field. I'm just going to go over to here and say, let's look at the rectangle, which is in raylib. Okay, generate me a macro that can create printer functions for arbitrary types like this. Okay, let's go to debug, and I'm just going to put out of that, and we'll put that here. So we have define printer, and then print field. And then we have rectangle fields. And then we have the call to define printer, rectangle fields. We still don't have this X thing. Oh, X is just whatever the first. Oh, but I didn't give it. Okay. Well, we need to also pound include raylib.h. There we go. So let's try to figure this thing out. Okay. I think this should be in the header file, right? Because it's not actually code. Maybe, I don't know. I think it should be in the header. So we'll just say mv source debug .h. And then if I do a GCC, or was it GCPP for the C preprocessor on that, we get all that, and then we get this rectangle print, and it looks like it does the right thing. Okay. I'm not gonna pretend like I understand. Let's try to understand it. So we have a couple pound includes, fine, and then we have some pound defines, and then we have a define printer, and we give it the type and this other thing, rectangle fields. Rectangle fields already maps to this, and define printer maps up here. So define printer is like a function style macro, so it requires a type and fields. Fields is yet to be defined, so we would have to go into rectangle fields to resolve that to provide it to define printer. Go into rectangle fields, that thing's also a function, but it does, we don't provide things to it. Okay. Oh, here's where we provide the field and the v. So it's saying you're going to provide me an x and an object, and then I'm going to call that x with the type of value of format specifier and the object itself. Okay, that makes sense. And then here's the actual definition of the function. So we say type and then underscore print. And then we're going to say printf, the type name, and then a curly brace. And then all the fields, for the fields function, we're going to print field v. So print field is the x, which is our printf. Which includes print field has 4 arguments, which is type, name, format, and object, which would be the name. I don't see us using type. Where's type? Use that. Do we even need this thing? I don't think we need print field to take in the type. It does need name. Does need font, which is how it's formatted. Okay. And then we also need the object itself. So I don't think we need this, right? We can delete all of that and then also delete this. So it's the name of the field, the format string for that field, and the object itself. And I don't even think we need the object, do we? Do we need the object for the, I guess we kind of do. Well, we don't if we assume that the name is conserved, but I think it's probably better to just pass it in. Okay. All right, that looks good to me. Let's go ahead and foreground. Let's go to our draw.c. We're going to go up here and we're going to pound include debug.h. And then we're going to the place where we draw the rectangle for the map. And we're just going to say, hey, rectangle print. And we give it rec. This thing's taking in, let's see, a pointer. So you just need to give it a pointer to the right, not a copy. Okay. Looks good to me. Alright. And then we go here to make. Oh, we got plenty of problems with that. Implicit conversion increases floating point precision. Const float to const double. Okay. It's all float to double here. Debug.h. So is it complaining about the format specifier here? What is the format specifier for printf for a double value? Technically these are floats, they're not. What about a float? Const float to double. Double, but float, since print is very addict, float would be promoted to double. Explicit by converting it to a double. Okay. Okay, maybe we need to provide the type for that. So in here we can just say, hey, type. Oops, sorry, not there. And I'll just be a little bit verbose with the parentheses. Okay, then over here we can give that type back, float. Okay. Provide the type. Make, clean, make. Did I mess that up? No. Oh, I need to say double instead of float. I think that'll fix it. Make, clean, make. There we go. All right. Build. Okay, we got a lot of rectangles here because we're doing one for every loop. Okay. if we go back to main.c, or actually draw, go down here, we'll just say return. And we'll do a make, bam. So we got these, their x and y coordinates are completely messed up. Are they? Yeah, they are. And the height is 0. Okay. So plenty of things to fix here. If we go back up to draw map. So our y position is equal to start. Start comes from here. We add on the height. So really the height is the thing that's being messed up here. It's page rows times the page row height. Page row height is equal to page height. Page height is equal to page width. Okay. So here we'll just say printf out the page rows. I think that's the thing that's messed up. We'll do %f or d, I guess. Page rows here. Oops, I did have a warning there. Okay, we'll give it a LD. Okay, make. Alright. Yeah, our page rows are coming back as 0. How is that happening? Pages. Oh, we did mod instead of division here. That would help. Okay. That seems to be working now. Let's go ahead and remove that. Okay. So we got our main page there. Should we have 2 of these? Okay, so 0, 0, the width is really big. I would expect its height to be bigger than its width, but something's going on there. We'll have to fix that. But then our y starts here. And I'll just do like a small space here. Start plus height plus, we'll just do like 100 UL here. Hey, there's a space there. So we got 2 little boxes. The widths are insane. So our width is probably page row width, which is going to be the page width times the pages per row. So if we make this 1, 64 cells times the cell size plus the cell margin. So that's the page width times that page per row. Maybe our page per row should just be like 8. Maybe that'll fix it a little bit. Yeah, it's a little bit more reasonable. So that's 1 meg. All right. Let's go back to main now, and we'll do a 3rd buff. Then we gotta start factoring the remote adders. That's another thing. So right now it's gonna be 3 stacked right on top of each other. But what we really need to do is start factoring the remote adders in. So let's go back to draw. Okay. So when we're drawing our map, it should be relative to the remote address. Trying to think through like how I want to do this. So you're drawing the maps. They're the major blocks of memory that people are going to be interested in like looking at. There's also always like gaps. So basically if the maps need to be in order, and if the maps are not right next to each other in memory, then we need to provide some type of gapping mechanism to illustrate that gap. So that's going to be when we're drawing our row, sorry, drawing the map. Let's go back here, draw maps. So we start at 0 for our cursor. We need to track the previous, and then here we say, hey, diff previous adder with cur adder, and optionally, and draw a spacer. So that's pretty much what we want to do. And this would be cursor is equal to draw spacer of some sort. So here the previous is going to be null. Auto previous is equal to null. So here we go through, we draw our map, we set current equal to cur next and previous equal to cur. Okay, so we've drawn one map and we set our previous and current, so there's going to be no nulls here, so we don't have to do null checks. And here we can say like if previous dot start plus previous dot len is not equal to, sorry, do it like this. Actually, I'll do it like that. Is not equal to cur dot start. Then we draw a spacer. And then up here, we have draw page, draw map, do a draw spacer. We don't need a map. We do need the start, turn start plus spacer height. Spacer height is going to be a const here. Sorry, const auto. Spacer height is equal to what? We'll do like 500 UL. And then we'll do our little thing here. Page width. I think that can be pulled out here. Static const auto page width. Pages per row, that could be pulled out. No, that can't be pulled out. Okay. Page height. Obviously. So basically anything dependent on pages will need to, this one can be, pages per row. That's cell stuff, this is page stuff. So pages, this one's dependent on pages. So page rows, page width, pages per row. This one can't be pulled out because it's page width times pages per row. Static const auto pages per page row width. Really, that's the map. I guess you can call it a page row. Yeah, you can call it that. Really, it's going to be the map width. So maybe we rename that. I think map width is a little bit easier to grok. Map width. And then map height. This would be the page row height, which is equal to the page height. Yeah. Static const auto that. Maybe we'll rename this back. I think it might be better to be called page row width. Because it might be subtly different between the page row and the actual map itself. Okay. We can delete this and this. Here we have X pause, Y pause, width and height, page row width, and then page row height times the number of page rows. Okay. This is how many pages, this is how many page rows. And then just a simple calculation to get the coordinates for the rectangle and draw it. And then we return with a little bit of margin. page rows times the page row height plus 2 times map padding. Okay. I'll call these green instead of black. And then in here, instead of drawing the map, just pull this down. We'll leave that one in the space since it's only related to spacing. Well, maybe we'll pull it out here. Okay. Okay, so in here we have basically this is the work that we need to do. Our position is going to be 0. Our Y position is going to be start. Our width is going to be page row width. Actually, this is going to be map width. Map width. Just do it like that. No sense in having 2 guys. I don't think I'll ever change that. So, and then down here, the height is just going to be a constant, which is spacer height. And down here, that's exactly what we want. We'll call this red. And then we have a spacer. It's going to be start plus the spacer height plus the map margin. Okay. Oops, make. Okay, we got some problems here. Okay, void star is not a structure or union. Previous star. Okay, so I'm not doing that correctly. So this needs to be previous start. What? Member versus base type void is not a structure or union. Oh, because that came out as a void star. Okay, this needs to be a map T. I'll just I don't know, I kind of like doing the right hand initialization. Map T star. There we go. Too few arguments. This does take in the cursor. Okay, there we go. Make clean and make build. Hey, we crashed. What do we crash on? Segmentation fault. Okay. Because previous is null, probably. Thought I could not. Let's just print out prev. Can I thought I had OG. Should that not be optimized? Maybe we need to go even further. O0 here. That's wrong. No, that looks right. Okay, I added on a length, which is a size T, onto a start. Prev, oops, prev. Can I do the addition here? Start plus prev one. That doesn't seem right. Okay, well, we know it's in that line. Oops, please go away. So I'm guessing prev start oh, the last one. Eventually current will be null. That's probably the problem. Yeah, so we say if cur is equal to null, then we just return. And I can take away that. Otherwise, you have a previous end. Okay, that makes sense. Let's go ahead and make clean that. Make. Where are we at? Build. There we go. Hey. We zoom out. We should get our spacers now. Yep. Got a little spacers with the margin. I wonder if we should dynamically size the spacers. Probably not, right? But these spacers need to be bigger. So let's do spacer height. We'll say like 10,000. And I think I can do this, right? That's like a C23 feature. There we go. Here's our spacer. It's a little bit too big. I think I probably want 5,000 at most. Boom, boom. All right. So the next thing I want to do is get maps that are right next to each other. This is map margin. I'm going to say maybe, let's go with 500. And then I want to test the maps being right next to each other. So main here. So this one, they're all the same size. It's just where the remote adders are. So that one's at 4096, which is one page off. And then this one is going to be at 1 to the power of 21. And it's a 1 to the power of 20 size. So 1 to the power of 21. Let's break out Python here. Okay, so we got 1 to the power of 20, which is a million. And then it's going to be offset by 4096. So that's the ending location for that first one. Wait a minute. Precedence rules. Okay. So we got 1 to the power of 20, 4096. That's where the ending address would be for the first map. Now the second map is going to be like that, a million off, so it's safe. And the third map is going to be there, which is like 4 million off, which is even further. But what I want to do is say, hey, what's that plus, let's get a precedence going here. I don't want to mess that up. 1 to the power of 20 here. So that's where we want to end. So whatever value we create, it should be that. Or whatever expression we end up with, it should be that value. So 1 to the power of 21. I guess I can just do this expression, why not? Let's ask AI. Simplify. Yeah, you can do 3 to the power of 20. Yeah, that works. Okay, we'll do that. And if we did 1 to the power of 21 or 2 to the power of 20, same thing. So we can do 2 here. There we go. Okay. See, now these should be right next to each other. So they shouldn't get a spacer. So let's go ahead and just print out these locations then. Kill this now. Where's it gonna be? Draw, C, draw maps. %D, %D, new line. This will be this value. This will be this value. Oh, sorry, not D. Maybe this shouldn't be a pointer, should it? I guess it's fine to be a pointer. Well, fuck it. We'll just do P. Oh, there's an A here. That's hard to see. So after I'm done with this, I'm just gonna return. Or can I exit? Exit. What? How come I can't exit? Did we not exit from here? Or did I just not rebuild? Okay. I probably just didn't rebuild. Why do we never exit? Fascinating. Our current is never equal to null. Like, what the hell is going on there? I shouldn't be able to zoom or do any of this stuff. This is insane. So current gets stored as previous. Current next gets stored as current. That's exactly how it should be, right? So this is the first one. That's the second one. Current is clearly nil here. Oh, freak, man. It's because I did a return instead of continue. Jesus Christ, is going insane there. Okay. So what do I just wanted to print out? Okay, make. There we go. All right, so we went from 2390, 890, EC8. Yeah, they're not correct there. Oh, it's because we messed up this start. Yeah. I think this is where we're confusing two concepts. We're confusing the virtual address space positioning with the visual representation. No, we're not. We shouldn't be. Because we're not considering cursor in the... Yeah, cursor is only being used in the drawing. Okay, so that's not the case. All right, so we have previous to the start of the previous plus the length. And the length is going to be size t, and so there's no point arithmetic issues there. I'm gonna say previous start len and then curve start. Okay. Okay, so we had the previous start, and then we added on same value, yeah. What's weird is we only have two. Oh, because cur. Yeah, that makes sense. We only have two boundaries. So the second boundary should have been the one that was true. If we go here to Python and say, hey, you're starting at this address. Oh, no. It's not start, it's remote adder. That's where I'm making a mistake here. Okay, so this is going to be previous remote adder. And remote adder is just a uint ptrt. Good, good, good. Okay. I think that'll work. Oops. Make clean. Actually, go back here. I just want to remove that exit. Make, and then we run. Okay. So we should get space between the first two, but not between the second. Yeah, because they're right next to each other. Cool. All right, we got our maps going. Now we want to draw our pages. Okay. So for each one of these things in the map, we have to draw pages. And then we draw our page itself. Okay, let's just do a draw page call then. Draw page. And that's going to take in the map, but I don't think we want to pass in the map. What does this thing need off the map? Okay, so it's going over map length. We definitely don't want to do that. And then map start. Yeah, we don't want that. So this will instead be a uint 8t pointer start and a size tlen. So that'll be like that, like that. So that fixes that. And then drop page. We're going to need to go over and do some type of looping here for something. Draw page. Oh, and draw page needs to be above this because it's being called from it. Bam. I'm just going to do like a little say constants. Okay. Alright, so now we have to iterate over all the pages. So you know how many pages they are, because we computed that here. So we can say for, what do we want to say here? Size t, I is equal to 0. I is less than pages. I plus plus. Okay, so I is the number of the page. So our start then would be map start plus I times the page size, which will be what? I guess we should pull that out as a constant, right? Up here, maybe? Static const auto page size byte size. I said 4096, but really what I should say is, oops, auto. No, I think that's appropriate. I'm gonna do a UL here. So page byte size. What's the name of that constant? Just put it in here. Okay. Times page byte size, and then the length is page byte size. Okay. So that'll be good for those two arguments, but there's other stuff here that needs to be taken into consideration, like the positioning of this. So that would be the X and Y start. And right now I just have it set to margin. Actually, no, that's not correct. Well, we're gonna need to do some other drawing here. I'm just gonna say return from here, and then we'll do some different drawing here. Here. This guy. I'll just grab this guy. We'll say page number. Page number is going to be a size t. Pass that into. So this will be just I. Draw a page, so I'm going to use that. This is all cell stuff, so I don't need that. Let's pull it down here. I feel like this will probably be a separate function, like void draw page cells. And then in here we'll go all this. For now I don't want to draw the cells. And these are going to need a similar signature here. Alright, down here, now we can just do this. The rectangle, I'm just do like black here. Why not? Page number is going to determine where we're in this grid. So the X position, we're going to start at 0. So it'd be page number times normally it would just be like page width, like that. but we also have to add in page margin. Need to fix that. So page width plus the margin. And we're going to add in that margin to begin with too. So margin plus the page number times the page width plus margin. But this isn't page number, it's going to be page number mod pages per row. Okay, that'll get us there. Our Y position is going to be something similar. It's going to be margin plus the page number divided by times page height plus margin. Sorry, this is going to be page margin, not margin. Okay. So that gives us our X and Y positionings within that, but then we also have to add on the visual start of the. So down here we have drop map, and it has this thing called start. I don't like this name start because it's sharing the same name as the start, which is the start of the buffer. And I don't like it, so I don't like start in general. But in here, I want to rename it to be Y cursor. And then down here, map start, I want to say code rename and just call that buffer, because that's what it is. It's a buffer. And if we go to the map definition, it is called buffer already. So that should work. Now down here, draw a spacer. This is going to be also code rename Y cursor. Then down here, reg start. That will be the start, but I want to rename it to be start we'll call it first. That stuff I don't care about. Draw page cells. Now this is going to be code renamed to just be buffer. And then those we'll figure out later. And here, this would also be named buffer. Okay. $175. Okay. All right, back in here. So we're drawing our page. We got our X and Y position. We need to add on now the cursor, the Y cursor. Yeah, let's do that. So here I'm going to say y cursor, which in the past has been a unsigned long. So y cursor plus all that stuff. Okay. Width is going to be map width. Height is going to be, sorry, width is not height width. Page width. This would be page height. Okay. Okay. So that's going to draw the page. Now, if we go back to draw page, here, we also need to pass in the y cursor. Which in our situation is a bit different. So this level, the y cursor is going to be the initial position. But we can say y cursor plus an expression where we take I times, no, I think we just pass in the y cursor. Because that logic up here is going to take that, add it on to its calculation. Okay, make, clean, make. Okay, we got some warnings here. Buffer and len in draw page. Well, we'll leave them in there for now. It's fine. We need to pass them into the draw cells. And then down here in map, we have start. No member named start. Yeah, thought I fixed that. Map. Oh, because I got a header and map.h. Okay, so this starts here. Buff. No. This would be first. There we go. Alright, so we just got those two warnings. Oh, it's black. I guess that's fine. I was expecting margin in between those. But it is drawing the pages on top of it, which is good. Draw. Okay, so we got... Okay, so we want to have a page margin. Did I not define that? Page margin. Yeah, I left it at 0. So let's just do that as like, what? 100? Here, I kind of like 100. I think it looks decent. So now the page itself needs to factor that in when it's drawing the page. Or sorry, drawing the map, I should say. So the map width needs to be recalculated. So that's going to be page row width plus 2 times map padding. Okay, this is gonna be page row width times wait a minute, page width plus page margin times the pages per row. And I think I need to subtract off the margin from that, but this should get us most of the way there. And then the height as well. Yeah, so that'll automatically fix the height. Wait a minute. Page height. Down here though, you need to fix the height calculation here. So it's going to be the same as this. Where am I? This guy here. So it's going to be, height is going to be the page rows times so this is the page width times the page plus the page margin. Page width plus the page margin times the pages per row. This is going to be the page row height, which is the same thing as a page row width. Sorry, page row height is the same thing as the page width. Yeah, makes sense. Plus the page margin. Alright, make clean, make, bam. Alright, so that should fix the pages not fitting. Yep, look at that, beautiful. And I feel like the spacers need to have some type of like text. Another thing is that I feel like we need a spacer at the beginning of the address space. Because there's going to be space up above there. Okay, so that's looking good. Let's get the cells back in. And then what I want to do is actually dump the maps of like a real process into the main, and then use that as a test fixture for iterating. But let's get the cells drawing again. So we draw the page. Now we draw the cells, page cells, and we give it the buff and the length. We also got to give it where it's being drawn at, right? So that's going to be, did we even use Y cursor? Yeah, we used it in the Y position. So I think X and Y is going to need to be provided here. X pause, Y pause. So this will be X, Y, and they're what? X and Y pause are unsigned longs. In C, what is a shorter type that is the same as unsigned long. I don't want to have to type that everywhere. What about a size T? But is size T to unsigned long? Okay. We'll just stick with unsigned long for now. Alright. What did he recommend for a pound define? Oh, he did a type def. I just want to type def or a pound define. Yeah, I think I want to do something like this. There we go. Alrighty. Unknown type name X. Okay, yeah, so this needs to be a, oops. Draw page cells. This needs to be a UL with that. Okay. X and Y. Okay, now we got some cells drawn in here, and of course they don't consider the margins. Now, I don't really want to draw them unless they're at a certain zoom level here. Like maybe around here. So let's go back to draw page cells. So this is this thing here for the shadow. Huh. Let's go back up here and we'll just do it here. Where's zoom threshold? This needs to be returned. Zoom threshold. Yeah, we'll pull that out up here. Should probably do the visibility check on these too, right? We need to fix the cell drawing too. It's 1, 2, 3, 4, 5, 6, 7, 8. Interesting. Oh, because of the margins here. Yeah, that's probably why. Oh, and these get... Okay, let's fix that. Okay, so assuming we are drawing the cells, really it's the X position that needs to be factored in. Length is going to be the length of the buffer. So I mod width elements is going to give us the number of things to draw. Width elements is the number of things to draw. And width elements is computed here, which is a 64 UL. Okay, let's pull this out here. This 64 needs to go up here. Static, oops. Const auto. Bytes. Cells per line. Okay. Cell size is going to be the size. So why do I need to have another name for that? Okay, delete that. Font size. That's reasonable. I am going to pull it out here though. Margin is cell margin. So why do I need that? Oops. And then offset. Cell offset. Okay. Let's make sure this builds. Does not. So it doesn't like the cell size. So this is the text. Cell width and cell height. There you go. Alright. Still gonna have that issue because we haven't added in the little gaps here. If we didn't have those gaps, then it wouldn't be an issue, I don't think. Let's remove the gaps then. So that's this boost stuff here. So boost starts at 0, and then we add stuff onto it. So if I just comment those lines out and do a make iPause. I guess I don't need that. Comment those things out. Make clean, make, and run the build. So now I think this should fit in to the page. Yeah, get the little margin there. The other thing we want to do is have it a little bit extra margin for the left hand side and start our X position on that margin. So here would be cell margin plus that. So that puts the little margin there, but now we're going to be missing it on the right hand side. So we need to re-add it. Which would be over here. The page width will be 64 times the cell offset plus the cell margin. Alright, so that'll fit that on there in both dimensions, but now we gotta like put the spacing back in. Alright, the boost. So we take I and we mod it by cells per line, which gives us the position into the cache line. And then we say, hey, if you are divided by 4, you get added on that. Okay, we'll pull this up to the constants up here. So the one that we're using to draw the width of the page, in fact, I'll go through and do this stuff. Pretty much anywhere I'm doing a rectangle, I want to do that. These are just test things, right? Yeah, I don't have to mess with those. Draw origin debug is a test thing. What was that draw bars thing? What is this draw bars? It's not being... Alright, I'm deleting it. Draw bars 1, 2, 3, 4, 5. It draws 5 rectangles. All at position 100. I think that was just a test thing. I'm going to delete that. And then this is draw a circle, calls draw a circle, but doesn't actually draw circles. Just going to delete that. I'm going to delete these debug things too, because I don't think these are very helpful anymore. That was for grid debug. Maybe I'll pull them into debug.h. The grid was a little bit helpful, but not anymore. Just delete that. Okay. Okay, we're good. So how do we add this boost onto it? Well, I could do the manual calculation, but it's going to be fixed on the size of the cache line being 64 bytes. So I think what we have to do is find out how many 4s and how many 8s fit into the cells per line divided by 8. Yep, divided by 4 and divided by 8. This is a number that we need to then multiply times the cell margin divided by 2. Alright, we're going to take the cells per line divided by 4 times the cell margin divided by 2. And since we're doing the divided by 2, there's going to be a plus here. Since we're doing divided by 2 in both of those, we can factor it out. So this whole thing, we can factor out the cell margin too. And then the precedence kicks in. We don't have to have all these parentheses. Be like that. Cells per line divided by 4 plus cells per line divided by 8 times cell margin divided by 2. We have another divided by 2 we can divided by 4 we can pull out. And divided by 2 divided by 4. is then gonna be, so we do it like that. And then that allows us to pull out the 4. The 4 would then be 8 here. And that would be 1.5 times cells per line. 1.5 times cells per line times cell margin. Scala draw. This is where I'd like to try out this. I got this Wacom tablet that I can use to draw, do math and stuff. I'm not really liking the configuration of it so far, but can I just do reset here? Yeah, I don't like the tracking of it. Alright, so what do we have here? Let's actually copy this and back out of all this until we get back to something that was like really caveman-like. That was pulling out the divided by 2. I just need to put that addition back, and then there we go. Let's try to get this to work first. Alright, what we're going to do with this? Well, we need to add that onto our calculation for the width of the page. So when we're drawing the page, the width is going to be the page width here. Go back here, cell offset plus a margin plus cell margin boost per row. There we go. Make clean, make. Alright, so we got our boosts back. And if we look at the width here, it actually is a little bit too much because we have one extra. So maybe if we go here and delete this extra, where is it? Addition of a cell margin. Oops. Let's go back here now. See if that lines up. Yep. Cool. Alright, and then when I'm drawing the page, I'm going to do light gray. Or purple. Just so the shadows show up. We'll go back and fix all these. Yeah. Oh, look at that. Interesting. So our height is not going to be the same. We got to subtract off of that. So if we go up here, page height is going to be different. It's going to be without this. So actually we can redefine this like this. That. Alright. Oh. But we do have to add on the margin to the height. Interesting. Okay. Well, we'll pull this back out here. Plus cell margin. There we go. So that's 1 meg. All right. All right. Well, I don't like this purple. Let me just change that real quick before I commit. Purple. What other colors are there? So it's light gray, gray, dark gray, yellow. Let's try for the pages, maybe make them dark gray. Oops. And then the maps. Let's actually make this gray. And then the map will make dark gray. And then the background of the whole thing will make black. Okay, this guy needs to be light gray. And then if we go back to draw maps here, so I don't like this because we're checking the same condition twice, and then we're also like going to be needing to draw the spacer initially. So yeah, well, let's implement it and then try to refactor after we have it. So up here, I just have to say if cur remote address is not equal to 0. Then we draw a spacer. Yep. There's our spacer. The other thing I want to do is like start the process zoomed out. Here, up here, I think what I want to do is say draw debug, and then void draw debug. Just gonna output the state of everything. In fact, I think I want to do this at the end of the frame. Draw debug info. So I want zoom. So what is this going to be? A text element. So draw text EX probably. That gives us font control. I don't really care about that. And we'll do our position in the upper left. So it's going to be 0, 0, 12, black, I guess. Zero, 0, 12, black. Let's try that. Okay. Let's make it a little bit bigger than that. Offset it by like, what, 20 pixels? We'll do like a dark gray, and make the font size like 20 as well. Okay. Let's quit that. Buff is gonna be like what, like a 4096, or let's do 1 to the power of 12. I guess that makes sense. 2 to the power of let's go to the Python. 1 to the power of 10 is 1024, but if you have like 6, it'd be 64, and 6 plus 6 as an exponent would be 2 to the power of 12, which is 4096. All right, 2 to the power of 12. What do I want to do? We can just declare it like that. We don't have to zero initialize it. Fuck it. I'll zero initialize it. Why not? We'll just call that buff, which is a char star. No, just char. Okay, and then we're gonna pass that here. Buff. In fact, I'll initialize it to that. And then we're going to sprintf, or snprintf, into that. This takes in the target buffer, the length, the format string, and then the arguments. So target buffer, the length, size of buff, the format string, gonna be zoom %d new line, and then we give it zoom or get zoom, and I think this thing returns how many bytes are written, something like that. Sorry, LD. Okay. Get zoom is a float. Oops. Float to double. Okay. Get zoom, does that return a float? Yeah. So that's zoom 1.0. If we zoom all the way out to like this. So that's 0.005. So we should probably set zoom initially to that, right? I actually kind of want zoom to be a double, but everything else is float, so whatever, doesn't matter. Alright, so that should get us zoomed out at least. And then we need to set our origin as well to be like here. We'll leave it that way, but what we'll do is we'll initialize origin. So that'd be a set origin colon main probably. So before I do my draw loop, actually, you know what? As I go into draw loop, I'm just gonna say set origin to a vector 2, and we'll have dot x is equal to something, and a dot y is equal to something. So this will be get actually no, the y should be a constant, like what do you want this to be? Maybe like 1 to or 2 to the power of 20 maybe, and then this will just be get screen width. That doesn't make sense. Divided by get zoom. Or is it times? Well, we'll try that for now. I thought it was going to be good. Okay, so zoom wants to have it float here, I think. Okay, build. Alright, that translate did not work at all. So that main draw loop, let's comment this out for now. Alright, so I think what I need to do is just say, like, instead of 1 to the power of 20, maybe just do a 4096 here. We'll keep it in the units of the screen until we know better. Look at that. Okay, so that should be maybe just like 200. Alright, so 200. The screen width divided by 2 didn't seem to work very well. I would expect it to be either there. Try it again. Yeah, it doesn't seem to, it seems to be like a permanent type of deal. Maybe I draw one frame and then do the calculation. Maybe that would give me more accurate screen width instead of doing it here. Frame count is equal to 0 unsigned long. Auto. And then if frame count is equal to 2, let's say, then we'll do a set origin call. Change this to 4. Oops. Let's add frame count into here. I think I can start doing it like this, right? pull this up here. Hey, look at that. So that landed at literally in a half, right? So maybe we do... subtract off the... this would be the page width times the zoom. What we can do is do this on every frame to get a little bit better idea if it's working or not. So that's not exactly working. It's bumping it over a little bit, but not enough. Oops. Maybe I just subtract off the page width. Is that gonna like throw it all the way over? Maybe. Yeah. Yeah, it doesn't work. Doesn't seem to have a huge impact. Oh, it's page row width, not page width. Times get zoom. That's why. Yeah. So I'll keep it one page. Yep. That's the reason why. So that should keep it mostly centered. Interesting. Times zoom also has to be divided by 2. Okay, so we put all this over here then. Okay. There we go. It keeps it mostly centered. Oops. So we only want to do that on frame. Oops. Frame 2. Actually, it should be frame 1. Okay, that worked. Can I do it on frame 0, or is that gonna like freak it out? Yeah, it freaks it out. Has to be at frame 1. Okay. Now there's a complaint in the compiler about, it's like a warning that I'm losing precision. Subtracting from an int with a unsigned long multiplied times a float. So it says implicit conversion from int to float may lose precision. Oh, because that expression on the right hand side is already assumed to be a float. Well, we'll convert this back to a int, I guess. What is get screen width as an int? And we'll throw this whole thing here into an int. And now it's complaining because of y. Huh? So this whole thing, oh, we need an extra parenthesis here, that's why. Think. So this expression here is then converted to an int, and then we subtract from the width. Okay, so now it's saying integer division used in a floating point context, possible loss of precision. None of these are floats. Like it's an integer, everything's integer. I don't know how to like everything's gonna be an integer. I'm gonna force everything to be an integer. See if this thing will go away. No. This is so silly. Alright, whatever. Let's go back here, make into float may lose precision. So here, I'll explicitly convert this to a float. There we go. All right. The performance hit when you get into this zoom level is just like kind of crazy. And the thing is, it's running the numbers for all this stuff. It's not stuck drawing it because we're culling things. But like even this kind of feels choppy. I think what I need to do is compute the frame rate. Yeah. Let's do that. Frame count. We'll do a frame rate here too. And that'll be a float. Oop. Oh, I can't do that, can I? So we frame count. I guess we have to do like an increment on the frame count and then subtract off the time. How should we do this? Well, like I could do frame count divided by the number of seconds, but that'll be the total average frame rate for the entire duration of the program. Whereas really I just want the most recent. What I've done in the past is I would have a separate thread that just is responsible for waking up every second, waking up every second and resetting the frame count back to 0. And that way, anytime you read it, it's like how many frames have been computed since the beginning of the second. You know, compute the frame rate, reset the frame count to 0. But having a dedicated thread for that seems kind of heavy-handed. Trying to think there's a way of doing it just like in a single thread. So we're doing our increment at the end of drawing. And the draw debug info also happens at the end of drawing. Except that it happens right before it. Thing is, like, we need some concept of time. And this Linux kernel scheduler gives us a really good concept of time because the thread wakes up. You have it sleep 1 second, wake up, sleep 1 second, wake up. So it gives us a constant signal of like every second. I might just do that. It's an implementation I've done 1,000 times in Go, and like it's very simple. I'd like to think of a way of doing it in a single thread though. I think what you have to do is like compute, or first you have to get the current time, and then you have to see, hey, you have to record the previous time you drew this thing, and if that previous time, if the current time minus the previous time is greater than a second, then you divide the frame count by that, and then you reset the frame count. So really there's going to be two things here. We're going to have a global frame count. So we're going to have a frame count and like a, I'm going to call it global frame count, and then a frame count, and we do the increment on both of them, which actually makes us feel like maybe it should be a while. Okay. Now when we go to draw the debug information, I guess we could do it here. I'll leave it out of there. So we go to draw the debug information. We need to compute the last time. And then this will need to be over here maybe. Last frame time. We'll do it like that. I think this uses standard library will use the what do they call it? VDSO for this. Time t. That's what we want, is time t. Which you might be able to get from saying time of 0? No. So that's a function call. So here, time t, and that'll be 0 initialized anyways as a global. Let's make these things static too. Import time.h. Okay. Higher precision, wall clock time, most common. So you just say, hey, give me time, and that'll give me now. Okay. Last frame time is going to be time of null. Okay, so now up here we need to say if, oh no, it's last frame time. No, I don't want to do that. Frame rate start time. There we go. doesn't say time. GNU no. 2 maybe? Okay, yeah. Time. Number of seconds since epoch. I do need a higher precision, I think. Clock get time. That's a little bit more complicated. Alright, I'll be back in a moment here. I need to take a quick bio break. Alright, so we're going to use this higher precision clock, which is clock get time. I'd like higher precision than seconds, but I don't want a complex, costly API to query this data. Okay, that looks decent. Alright, we'll throw this thing up here. This is in time.h, right? Do I need to do the GNU source trick thing? Man, clock get time. It's in time.h, but I might need the GNU source thing. Source, yeah. Feature test macro. pound define default source. Alright. If I delete that, it starts freaking out. So, need that. Frame rate start time is going to be a float now, or a double. Now seconds, and then we say, hey, if now seconds subtract frame rate start time is greater than 1, then we say time delta is equal to that. Oops. Time delta, then frame rate start time is going to be equal to auto now is equal to that. Now, and we can compute a rate from here. Frame rate. I guess it starts with 0, that's fine. Frame rate is now equal to frame count divided by delta, time delta. And then we set frame count to 0. So we just go in incrementing these two things. Frame count and time is increasing. As soon as time delta is greater than 1, then we reset and we compute our rate as the frame count divided by time delta. We reset our frame count and reset our start time. So this is going to be frame count, global frame count, and frame rate. And then zoom. Okay. Make, clean, make. Alright, it doesn't like frame count divided by time delta because unsigned long to double. So if I convert this to a double, make, clean, make, okay, build. Frame rate is 60 frames a second. And the first frame, oh no, I'm getting glitches. It looks like it's repositioning back to center once every blue moon. So that means that this set origin's probably because it's frame count instead of global frame count. Okay. So we go from 60 frames a second down to 8. And when we get closer, it doesn't really, it improves a little bit. We get into 10 frames a second, 9. But basically it's not the culling. If the culling was working, then I could just do this and not draw anything and get a really high frame rate, but I'm not. Let's do some more things. I like computing how many objects were drawn. That should be fun. Let's go up here. We'll call this a auto draw. Actually, we'll call this a UL draw count. So every draw I want to increment. So draw rect, so draw count plus plus. These are all my functions. There we go. Oh, and there's draw text here. I guess we can throw that in there. Because it's debug, I'll leave it out of the count. Whatever, I'll include it. Okay, there we go. Then I need to pull this up. So this is 774. Then when I hit 0.1, it goes up to 10,000. But if I pull over here, it goes back to 774. I might get that down to like 0, but that's not the problem. The draw calls are not the problem with performance. Because you can see like 10 frames per second. But then if I like put everything in here, it's still going to be around that 10. And then if I go over here, I guess it does have a significant impact, but it's not the main contributing factor. I mean, it's a difference between two more frames per second versus uh, versus 50 or 52. So what we need to do is like short circuit the math entirely, like we're doing here, where we say, hey, I'm not even gonna. It's not even that I'm not gonna draw. I'm not even gonna compute the positions of these things. So I think we can do that by like culling the pages, the drawing of the pages, and then that will cull the drawing of the cells. Because all the cells need to be contained within the page. So if we do draw page again, not draw page cells, draw page. See, we're doing this culling here, but we're doing the computation of all the. This is the wrong place to do the culling, basically. So I'm gonna say. I mean, obviously you don't want to draw it, but I think we should do this on the page level. So draw a page here. Maybe we should do it on both levels. Gives a little bit of a performance improvement, why not? So we create a rect and we say, hey, if it's not visible, let's just do that and return. Like, don't draw it, don't draw the cells, just return. Okay, so let's see what our frame count is when we zoom in here. See, that's a problem right there. It is visible, but it's culling it. But we still get a decent frame rate. The problem is that these things are getting culled erroneously. Because it's testing the upper left and the bottom right, but it also has to test the lower left and the upper right. So let's go to this visible rect. We need to do that. So A, B, C, D. C and D. Okay, so we'll call this upper left. This is going to be lower right. So this will be upper right and lower left. Okay. So upper right. It's gonna have just rect Y. So rect Y being the upper position. So it's upper right. And then this one will be lower left. be here. So lower would be y plus height, left would just be x. Okay, that looks correct to me. Alright, zoom in. Should not get that issue anymore. Look how fast it is too. But then we hit something here that's very strange. That debug, I need to get the debug to have a shadow because I cannot see it. So we're going to draw text twice here and just say drag down to black. Sorry, black. Draw that first. Draw it at 21. 21. There we go. Oh. So this is where we zoom in and like none of them are visible. Because none of the points are in there, but we are inside the point. There we go. Okay. So that is indeed an issue. Let's pull this maybe out 2 pixels. Dark gray. Maybe we do this as dark gray. And then this is light gray. I could also just draw like a bounding box around it, like a transparent bounding box. My LSP died, I guess. Okay. Now draw text, draw rectangle. Pro maybe? Is this color, oops. Is this color type, does it have opacity to it? Oh, it has an RGBA. Okay. Maybe instead of dark gray, we say light gray and gray. And if that doesn't work, then we'll draw a rectangle with some opacity. I think the rectangle might be a good idea because it doesn't show up well in the light colors. Measure text. This will be a buff, and this will be 20. And then we're going to call, so measure text returns an integer, which is the width. Measure text ex gives you a vector. What if there's a height? I bet you measure text ex will give you back a width and a height. I'm not going to bother with this for now. It's debug code after all. Let's delete that. We'll make this thing dark gray. And maybe we'll space it out even more. 24. Okay, let's fix the culling issue. So if we go to visible, what is this? So the visible vector raw, or visible vector for that matter, those are correct. You can tell whether a point is on the screen or not. The problem is that we have these points, but we might be zoomed in to where we're completely inside the object, or partially inside the object. I guess you would have to be completely inside of it. So what this says is that one of the corners is on the screen, and so we're going to draw it. But at some point when we zoom into it, the corners aren't on the screen, not because it's translated away from the screen. It's because we've zoomed into it. So we have to say like and we'll say auto corner on screen, and then here we say return corner on screen, or we are screen inside rect. So here we say auto screen inside rect. And how do we take care of this guy? So this is going to be okay, well, let me open up a browser here, Excalidraw. So, alright. Let's get a tinier brush here. Cool. So we have our screen. This is our screen. And then we have the rect that we're zoomed into. But we could be like partially zoomed into it like this, where the rect is like that. So that's a case where we want to handle it. We could be totally inside of it. So I don't like the screen inside rect. Corner on screen or... maybe that is a good way of saying it. So we computed these vectors relative. So we are in, we take the rect. I think I need to rename this to an R rect. So now we have both. The rectangle we take in is okay. We take in a rectangle that has not been it's in relative coordinates. So I think this actually should be srect for screen. Could rename, we'll call it screen rect. And then this will be, what's the coordinate space? Am I calling it relative? Call this R rect, or just call it rect. I think if I go to relative.c, oops, sorry, relative.c, in here, I don't like the naming of these things. Oops. Just close that out. Relative.h. Relative.h. So there's two spaces. There is the screen space, and then there's the relative space. So I want to rename this to screen vec to relative. Screen vec to relative. Then this would be relative vec to screen. Oh no, I must mess that up. This one here, you take in the vector, this one's going to be relative vec to screen. Yeah. And then this one's going to be code rename screen vec to relative. And then this one is going to be code, let me write all that out. Code rename. This will also be relative rec to screen. You give it the relative rec and it turns it into the screen. And then this will be relative font size to screen. Okay, I think that's a little bit clearer. So now I'm going to go into draw, visible, here we go. So the first thing we say is, hey, relative rec to screen. Screen rec, so now we have both. Using the screen rec, we could say create these coordinates using our screen coordinates. And then this visible vec raw, I need to rename that. So it's going to be screen vec visible. Yeah, screen vec visible. And then we want to say, is the screen inside the rect? So now I got to bring back the Excalibur. So in this situation, we already handled the situation where we have, let me grab my pencil here. Like this is our screen and this is our rect. And in that situation, I guess if we were to like make quadrants out of this, it's kind of like these different quadrants here. And that only occupies, the corners of this rectangle only occupy 2 of those. Whereas if it were, well, I guess you could have it here and it'd still be visible. The other thing I was thinking about doing is just testing for the center, but that's not going to work. Because you're just further subdividing the rectangle. Now you're testing a rectangle, 4 separate rectangles inside of that rectangle. I think what I need to do is, I'm just going to reset this. And we'll create a screen here. And then we'll create some shapes that have different colors here. Just do green here. Bam. Okay, so this is one. This one over here. Just make that gray because that's not one. Can I send this to the front? How do I do that? Layers here. Okay. So this one we already have. So that one, let's make blue. These are the ones that we don't have. This one would be easy to test because the vectors of this rectangle reside inside of this rectangle. So in that situation, like if you're zoomed fully in, then you can be like, okay, just do the inverse test instead of it. Instead of is any points in the rectangle inside the screen rectangle, you say, are any of the points of the screen rectangle inside of the rectangle we're testing? That's the inverse of what we're currently doing. It would be, you know, just a twice as much computational effort. And it would get us a good amount of the way. But there are these edge cases like these bars here, where like none of the screen's vectors are inside of the rectangle's vectors, and none of the rectangle's vectors are inside the screens. But they do have space that's overlapped. So what I could do is I could just handle this case and call it a day, because I'm getting up on my allotted time for this stream. But really what I need to do is solve vector overlap or rectangle overlap. So one of the properties that we can see here is that like these positions are inside, but it could even be like this, which is kind of like what that is. But that this would be caught by it being inside the screen, so it has to be like this to not get caught. So this is saying the screen is within the Y range. The screen the screen's Y range is contained within the rectangle's Y range. There has to be a contained relationship, and I think that's between the Y ranges. And the X ranges independently. So I think what I'm thinking here is hide that. Hide all this. Actually, I want the screen rect. We can delete that for now. So that's not what I want to do. So we gotta say like, is A in B's Y range? If it is, is B in A's X range? Or vice versa. Basically, is there a Y overlap? If there's a Y overlap, is there an X overlap? I think that's really what we want here. So we say auto Y overlap, and then auto X overlap, and then here we return Y overlap and X overlap. So you have to have both, one of both. Is there a Y overlap or is there an X overlap? So this would be an overlap. Let's add that function here. Bool overlap. And we're going to give it 2vex. This is going to be A and vector 2b. I think we want to keep this stuff to catch these situations, but let's just try to do it just overlapping. So A, what's weird is we're only dealing with, I don't like these vectors because they have X and Y coordinates. So maybe we say like A, Y, Y, B, Y, B, Y. So this would be A, Y, A, A, Y, B, B, Y, A, B, Y, B. And these are all going to be floats, yeah. float. Okay. This will be screen rect dot y and screen rect dot y plus height. And then we're going to go with 0 and our get screen height, which will be our bottom right vector here. Bottom right dot y. AYA is less than BYA, which is less than, and BYA Let's try to develop all the test cases here. So this is the one I've been thinking of. You can have this one. You can also have this one. Send this back up here. Screen rect visible. Yes. Overlap. Height. Oh. Screen rect dot height. So you have AYA is less than BYA, true. BYA is less than BYB, true. BYB is less than that, yeah. Because you could have like this. That's no bueno. I guess you got it like this. That's gonna catch this. Maybe we can do it without this. Sorry. This here. So to catch this, you'd have like a situation like this. So this would fail this test. So you have AYA is less than BYA, and BYA is less than BYB, or AYB. Oh, this is so annoying. So that's an obvious test case there. Why is this always Y's? We don't want to consider the axes. So AA and AB, BA and BB. There's no dimensionality to this. Just one-dimensional overlap. Well, that makes it easier to think about. If I just think about it as one-dimensional overlap, let's just do a number line here. Oops. Why does that not want to draw? Oh, because I don't have this thing on here. Bam. So we have our number line. We have our test box here. It's like our screen. There's only so many permutations that you can have here. So you can have it like this. You can have it like this. You have it like this, and you can have it like this. Oops. So let's flatten these out. I'm gonna give myself empty that. Bring this up here just as markers. Yeah, we'll just keep it like that. It could be like this. I'm going to bring these guys up here. Okay. So there's the 4 different situations you could have. I'm going to actually move this guy up here and copy that. These are the 4 situations that you have that can be included in the range. It's almost easier to identify if you're outside than if you're inside, because there's, if you look here, this is very clearly out of the range. We'll make this what? Green. And then the other one on the other side. So there's only 2 things to test for to get the green, whereas there's 4 things to test for to get the purple. So I'm thinking we test to see if they're not overlapping and then negate it. So maybe just call this not overlap. One-dimensional not overlap. And we have A and B. So there's 2 cases here where we say A is less than I guess you could have like inverted versions of these. Just kind of then inverted the where you have the rectangles that aren't drawn from top bottom to lower right, top left to bottom right. That's when, like if you draw from the bottom right to the top left, it's kind of like an inverted version. I guess we don't need to consider those. So in the world where all rectangles go from left to right in this situation, then we could say AA is less than BA and AB is less than BA. So we're saying both of them are less than the left. So it's AA is less than BA and AB is less than BA. So that means it's not overlapping. Or we could say AA is greater than BB and AB. I guess we can just assume that that is the case because, yeah, so we make some assumptions here. So we can just say AB is less than BA. Yeah. Okay, and then we just do that in 2 dimensions. So we say not overlap in the Y dimension, not overlap in the X dimension. And we just return that. Turn and so you say screen rect Y plus screen rect height 0 and bottom right Y. X plus width 0 bottom right X. We say they're not overlapping in that dimension and they're not overlapping in that dimension. problem is that you can have a situation where you're overlapping in one dimension but not overlapping in the other, in which case you don't want to draw that stuff either. So I think we need to negate this operand, negate the operands and change the operator. We pull De Morgan's type thing. No, just negate the operands, which forces us to be overlaying in both dimensions. Yeah. So we can just say, instead of not overlap, let's just code rename this to be 1D directional overlap. Didn't like that. 1D, oh, it doesn't like one. Directional overlap 1D. And then we'll negate this. So we're overlapping one dimension and we're overlapping another dimension. I think that forces it, yeah. All right, well, let's make, okay, we got some issues here. Inverse relative rec in input. So that's gonna be, pull this out here. Go to my relative.h. This is going to be screen vec to relative. Screen vec to relative. And then this will be relative vec to screen. Okay, so we got 703. Looks like it's working. Let's zoom in. Yeah? Oh, we lost the text. But the draw count here, I guess we got 2 for the overlay here. 1, 2, 3, 4, 5. I count 5, but it's saying 11. But I mean, that's like just a constant factor off. I guess there's 1 for the map. There's 1 for the page. There's 2 for the drawing of the text. And then yeah, I mean, this is 11. 11 is 2 for the text, 2 for the, I guess there's another text here too, right? That's not showing up. Why is the text not showing up? I guess that's the other thing I need to figure out here. But looks very, very clean. The culling is working very well. All right, let's figure out why the text isn't loading. So when we go to, oops, vim draw.c, if I look, so I'm gonna go ahead and delete this. I don't think I need this. Or this. In fact, I don't even feel like I need this visible bottom right thing. It's only used here. We write it once. I feel like it's not worth optimizing that. Let's go ahead and just delete this. And then we'll do bottom right Y would be get screen height. Bottom right X would be get screen width. There we go. here. We can delete this call here. Okay. Make. Okay. Get screen height. Those are floats. This is integer. So I just need to say float here. And then the text. That's what I was going to do. So we're drawing the cell. So the cell is drawn. We got past the visible rect thing here. The zoom here, that might be the thing that's messing us up. Alright. Nope. It's not that. We definitely get to draw that, and then we go here, auto byte, all that, vector. Draw text center. Well, we'll just printf it. Yep. Alright. So it's definitely issuing the draws. Maybe it's the color? Font size, font text spacing, color. It's just not showing up here. Like it's drawing it, but it's not showing up for some reason. Draw text center. Oops. Text, maybe do a text position where it's just the cell position, because we know at least how to draw that. So that would be this guy here, rec. Rectangle.x, rectangle.y. So that would be my text position, font size. Why don't we just make it 12? Alright. Yeah, it's not showing up. We definitely have text rendering because I can see this guy up here. Why is this thing not showing up? Jesus. Why did how did this break? Printf out. The text position. Maybe it's something to do with the centering math here. Maybe. Position. Screen vector relative. No. That's the problem there. We want to go relative vec to screen. That's probably it. Yep, there we go. Alright, so let's go back down to where we're calling this. And restore this. Delete this. Let's see if we can get our stuff working here again. Yep. Okay. Dark gray, I think. So I guess the problem here is like we don't go under 50 or 56. Let's see, we got 8 plus 9. So that'd be 9 from 15 would be 6. So we went from 7, 15 to 7, 8. So that means that we were already drawing the map there. This would be another 8, which would be what? 8 and 5, 23? Yeah. That means we're not calling the maps. That's what it means. Which you probably should do. So when we go to draw a page, sorry, draw a page up here. We say, hey, are you visible? If you're visible, we'll draw you. Draw a map should do the same thing here. Oops. Didn't mean to return. So map margin is a constant. Height is a constant. Oh, but we calculated it there. So I'm gonna say ret here. ret is equal to that auto return ret. There we go. So when I'm all the way over, I have 4 things, 2 texts, and then 2 other things I have no idea what they are. But when we zoom in here now, we should get a plus of 7. So you go from 4 to, what would this be? We're adding 8, 9, we're adding 9. So it'd be 13. Yep. And then another 8 on top of this, which would be 8, be 21. Yep. Cool. I guess the text I want to clip in maybe about here, which is zoom of 3. Uh, 0, 1. If it's less than the zoom threshold, we don't even draw it. So I think I can get rid of this. I don't think that's doing much. Okay. Oh, and I wanted to bring this thing back. Get zoom is less than zoom threshold. I mean, return so early there, but this would be for times 3. Okay, I think we're in a good place to call it for the day. I'm getting pretty hungry. Yeah, we got maps, we got everything working as expected. I think next session I'm gonna load in the maps from a real process, and then display them using this. That'd be fun. Cool. All right. Yeah, I'll be on tomorrow, Wednesday. Don't have a lot of stuff going on, so I'll be streaming working on this. Cool. All right. I'll see y'all later. Bye.